All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the summer 2022 semester at George Brown, and it's week 14, part 2 of our broadcast and recording. Let's try and make this a bit of a quick one as we move into the last part of our semester. Let's take a look at what we did last week. Last week, we talked about utility theory and action execution. And as mentioned on the lab on Tuesday, we completed lab 7 for the most part. There were some people who did not. And this week, what we're doing is tactical and strategic AI. And we've, for lab 8, that's due this Sunday, we've added more actions. And the other thing that we've done, the only action we really added was the attack action. So this is the attack action. And what we also did this week was talked about creating torpedoes, which are like bullets. Okay, that's kind of what we did. The other thing we also discussed was the animation system a little bit to help out, which something that you could have gotten from Alex as well, if I'm not wrong. A couple of things to note is that assignment 4 is now changed. It's moved out to next Monday instead of this Sunday. It's moved out to April 15th at midnight. That gives you an extra day. And it accommodates, your work on the lab 8, which is worth 4% of your final grade. Another thing of note is that next week, assignment 5, which is your final presentations, will be hosted mostly on Tuesday. That's when we're appearing live. So this is what I'm going to tell you about appearing live, because this is something that's kind of gone up and down this semester in terms of remote teaching and learning and actually physically being there. Supposed to be there this week, but I'm kind of following Philip's lead for this one. He's the professor, of course, in game production, and just so that way it makes sense that you guys, have your time optimized. I elected to kind of put things remote on Tuesday as well. However, regardless of what's going to happen with Philip next week, whether he decides to be in person or not, we will be in person on Tuesday. It'll be the last time I have a chance to see you guys for this semester. And it'll give us a chance to take a look at your projects, the assignment, the final version of assignment 4 that I'm looking at seeing on Tuesday. So whatever you've got on Tuesday, please show up. That's kind of taking the place of your final test for this course. So it's kind of mandatory that you do so. The plan for Thursday is that we do a lecture on machine learning. However, let's see how it goes with your final presentations. We may do some of those as well on Thursday remote. So Thursday is going to stay remote next week. But Tuesday, we are in person, just making sure that you know that officially, no matter what happens. Okay, we're sitting at kind of the bottom of semester here. We've got lesson or week 14, and we're talking about tactical and strategic AI, waypoint tactics, tactical pathfinding, coordinated action, a bunch of other stuff this week. Next week, like we said, is your final presentations and machine learning, and specifically with Q learning and reinforcement learning and how that works with AI. I think it's an interesting topic. It's definitely an enrichment topic, as we will not be kind of having an example on how to do that again. Any questions before we move into the main topic today, which is tactical and strategic AI? Right. If you do have questions, and if you need something, please stay around after class, and I'll see if I can help you out with that issue. All right. So yeah, tactical and strategic AI. What is it? So far we've looked at a bunch of different decision-making techniques. Again, the second half of semester has all been about decision-making, right? And usually they are, all the ones we've talked about so far are really for a single character or class of characters. So what I mean by that is you can make a single character a range combat enemy or a close combat enemy or whatever loadout that you feel like you're going to put together. And even if you had multiple versions of these characters coming up to the, coming into your game, they're all going to work independently, which means they're not going to do any kind of cooperation or anything else like that, the way we've talked about them so far. So they're all independent AIs, okay? So what we want to do is think about what happens when they work together? Can you make your AI work together? Almost like have some kind of strategy that they're going to use when they're working against your player. So this is another topic, a little bit more challenging to put together. So let's talk about this framework on how this is kind of something that's going to work. So again, when we think about our AI structure, I think that this is our model that I've kind of shown this picture, and so has Alex, multiple times throughout the semester here and there. And really what we thought about originally was, okay, we need some movement. That was where we first started this semester. How do we move around? We talked about things like, steering behaviors. We can use steering behaviors to move around. Pathfinding, right, to kind of find the closest path or the best path to get to, the goal of the AI. And we talked about before that decision making. So it's almost like we built a foundation of movement, and then we added decision making as a layer on top of that. And now we're adding strategy as a layer on top of that. So how do we add strategy when it comes to decision making, which is kind of interesting. Of course, all of this feeds into our animation and physics subsystems. Physics we're going to be dealing with to some degree next semester. And then you'll probably get more physics in the following semester. So physics is kind of like a two-parter. You get 2D physics next semester and 3D physics the semester after that. Okay, that's typically how it works. But that's kind of our little subsystems that we're talking about as part of our game engine. So strategy fits in right about here. Again, if you think about it, AI gets its information from the world, right? We get, we make decisions based on, like we've talked about many times in the past, input. We have some kind of input, right? And then we use our a decision-making subsystem to decide what to do, and then following by some kind of actuator to move around or use locomotion to move our character, our autonomous character, somewhere around the game world in order for them to perform whatever the necessary action they want to perform based on their goals and the right decision, that they need to make, something like that's appropriate for them to do. So if there's if there's a player that they want to attack, they're going to either have line of sight like we've talked about, or some kind of attack action that they're going to perform. Maybe they're going to run away, all that kind of stuff is in this model. So one thing that we can talk about when it comes to strategic AI is to have some kind of tactics. Tactics almost is like our strategy. If I'm playing chess with you, as an example, or Monopoly or some other, kind of board game, Risk, whatever you like to play, if you like any of those kind of games, there's always some kind of strategy. Part of it is, it's especially when it comes to turn-based stuff, I move and then you move, right? Turn-based strategy games. In real-time strategy games, typically what we do is, I move and you're moving at the same time, right? As an example, a lot of times it's not turn-based, but rather, you have a situation, your game world is evolving as you go, and there's a timer, that's kind of world time is something that you can speed up or slow down a lot of times. And in many ways, what ends up happening is your AI is working along the world time, whatever that happens to be. So we want to think about strategy. I want to be able to make the right move as an AI to defeat the player or to create a conflict, a level of conflict to improve players' immersion, which is really why we want to put AI in the game in the first place, to give them a challenge. So that's part of the game. The game aspect is to have fun. A lot of times we want to be able to be challenged, right? We want to experience something that's realistic. As an example, sometimes the AI is not there to challenge us, but actually to accompany us as an NPC or something like that. And what we're talking about today is how do they use tactics to defeat the player or to create that challenge, combining with other people, almost like a team-based AI, if anything else. So the first thing we want to talk about is something called a waypoint. When we know what a waypoint is, and you guys have used something like that when it comes to patrolling around the screen, it is a single position or vector, if you will, in the game, right? And we've seen them, we've called them nodes, we've, maybe representational points, something. We've seen these kind of things before. Pathfinding uses kind of like intermediate points, if you will, to go from one position to the to the final position. So that's one thing that pathfinding does. And this was the original use of waypoints, right? Some kind of technique for me to get from point A to point B. Okay, that's kind of the original piece for it. And when waypoints are used in pathfinding, they represent nodes as part of the pathfinding graph, if you will. And again, we think about what they are is there's some kind of connection from one node to the other node. That's what they are. We also talked about quantization, right? Or and localization. I don't know if you remember back in the when we talked about division schemes for your pathfinding. I know Alex may have talked about division schemes, and the way we did it to divide the world from a pathfinding perspective in our course is we broke it up into a series of tiles. So tile-based pathfinding. Each tile is representative. It could be a node as well, right? And there are connections from one tile or node to another node, usually in the form of neighbor connections. That's how it works, okay? And there's also often a cost to go from one tile to the next tile, right? Or some kind of a cost to go from one node to the other node across a connection. Typically, it has to do with terrain in the real world. That's how it kind of equates. Terrain or some kind of increased cost based on the game world layout, whatever that is. So what we want to do is when we want to use waypoints, this idea of points in the game world tactically, we need to add more data to the nodes, right? And the data that we're going to store is going to depend on what we're using the waypoints for, okay? And so far we've been talking about pathfinding, right? So we have a couple of things, a couple of properties that the nodes are going to have. Most likely neighbors, maybe an array of neighbors or neighboring points, part of their graph, right? What can I connect to? Sometimes there's only one way. I can only go forward, but I can't go back. It's not something that I can do. Almost like a directed graph, a one-way arrow that goes out from a point but not coming back. Okay, but waypoints for strategy might be used in different ways. So when it comes to waypoints for strategy, we can use them to describe tactical locations, and sometimes we call these things rally points. Okay. And one of their earlier uses in simulations is to mark almost like a fixed safe location for AI to gather in a losing firefight. All right. So let's say, for example, they're in some kind of firefight or they kind of gather in this like safe space. It's a rally point that they get to. They might go there to heal and, kind of rearm themselves, give themselves more ammo, that kind of thing. Call in reinforcements and those kind of things. Typically, that's what waypoints are used for. So it's really the same principle in real world military planning. When a platoon, somehow engages the enemy, it'll have at least one predetermined safe withdrawal point, that it can retreat to if the tactical situation, gets out of hand, right? And we need to retreat. Some kind of retreat point or an exit or something like that where they want to leave the engagement, the combat, whatever it's going to be. Okay. So again, much more common in games, though, is the use of tactical locations to represent some kind of defensive locations or cover points. And that's interesting when we talk about cover points because in your assignment 4, we talked about how to move your AI behind cover when it gets hit. This is the ranged combat enemy that we've talked about before. So you get your ranged combat enemy and they get hit, they got to find the closest point, the closest cover point, if you will, that they're going to go to, right? Again, in a static area of the game, the designer will typically mark some kind of locations behind barrels or protruding walls as being good cover points. Now, this is something that you can do for assignment 4 as well. So remember assignment 4, what we said is that the autonomous character, your ranged combat enemy is going to look for the closest kind of point, behind cover, some kind of, wait behind cover, go to cover, one of those kind of things. What I've told you so far in labs is that they're going to find the closest point based on where the current player is, right? But it's not like you couldn't, kind of put together a hiding location almost like a go-to point in world space that you're gonna assign to the enemy, all enemies. So a good example of that is, let's suppose you have a fixed obstacle in for assignment 4, right? Because nothing in our assignment says that the obstacles need to move or are randomly generated. Remember, you're going to be creating a curated map, something that is going to be determined ahead of time. It doesn't have to be something like there are labs that you can move obstacles around all over the place, which means that you're already going to know probably some safe locations for the for your AI to move to, right? Which means that you could select the closest one of those cover points based on where the autonomous character is on in the game level right now, right? So let's say he gets hit by a player, the player's moving around, and they're going to move to the closest cover point away from the player, right? Someplace that the player does not have any kind of line of sight. All right. So if you make strategically, if you kind of put this together in your level, some cover points, no matter where the player is, there's always going to be some cover point that has no line of sight. That's where it can go. And you can use pathfinding or obstacle avoidance or something for your AI to get there. It's really up to you how you want to perform that movement. But one thing that we don't want for assignment 4 is we don't want you to go right through obstacles. That's not allowed, right? You need to kind of navigate around them. So really assignment 4 is a culmination of everything that we've talked about so far to date when it comes to movement and decision making, okay? Going back to this, right? So you've kind of made these static points. And when an autonomous character engages the enemy, it will move to the nearest cover point, like it says here, in order to provide itself with some shelter, right? Other popular kinds of tactical locations are sniper locations, that's another type, which are particularly important in squad-based kind of shooters. So you're allocating this one to not only a cover point, but a sniper point, someplace where your autonomous AI is going to move to in order for it to attack your player. So really, the level designer does all this work. They kind of mark the environment as a cover point or a sniper point. Now, there's nothing that can't stop you from doing that as well for your assignment 4. You can look at your map and kind of say, okay, this is the place where they're going to go to cover. This is the place where they're going to come out of cover and attack the player if they're within the right distance. So all kinds of stuff that you can predetermine to make your A4 a little bit easier. So there's unlimited different ways to use waypoints to represent tactical information. And depending on the game you are creating, there's all kinds of tactics that your characters can follow. And for each of these tactics, there are some kind of corresponding tactical locations in the game, either positive locations that help the tactic or negative locations that go against the tactic. All right. So almost like a place where it's positive or negative. I always kind of think to myself when I'm watching the old Star Wars movies, Anakin, I've got the high ground, that kind of idea, which is kind of a tactic in some ways. Getting the high ground might be a tactical location, in a 3D game, because maybe, in the game itself, it's going to give you a bonus to hit or damage or something like that, some kind of buff that you're going to get compared to if you're kind of in a valley or something like that, which is kind of similar to what happens in real life. Mostly it's about visibility points though. All right, so most games, again, that use tactical locations, again, we're talking about waypoints as tactical locations, they don't limit themselves to one type or another. The game contains a large set of waypoints, each labeled with its tactical qualities. So now this is new, all right? Again, it's not just about pathfinding. It's not just about connections. It's also about tactical quality. All right, so this is kind of something that you can build into your path nodes if you think about it, right? And we've called them path nodes for a reason, because they're a way of you navigating from point A to point B to point C, all the way to where you want to go. Okay, and remember, you can always seek to a particular point. You can always look where you're going, and you can always perform obstacle avoidance or some kind of pathfinding algorithm to do that, like I mentioned. So in practice, locations for cover and sniper fire aren't that useful as part of a pathfinding graph. So if you think about this, it's not about finding the closest point around something. It's trying to find, where I am in terms of cover, shadow, or sniping. Okay, so those are the kind of points we have here. So here's some examples. You have, a point that's here that's really great for cover or shadow, but not that great for sniping. And the reason for that is because of its location. It's not like if the player was here, as an example, it's not like an autonomous character in this position can snipe, because there's obstacles in there to give them cover. But at the same time, because it gives them cover, it doesn't provide a great place to do any kind of sniping, if you will. So here is a great place for cover, but not really too much shadow. Shadow is really great for hiding, right? So if you want to also provide a place for your AI to hide, let's say in a dark corner or something like that, that's also a bit of strategy. And that's what we would do too in real life. We'd kind of hide somewhere where we can't be seen, come out and try and surprise our enemies, because, getting the drop on somebody is always better, in terms of strategy. So here again, this is shadow and sniping, but not much cover, because the cover is way over here. So this is where the cover is, and this is where the location of the AI is. So example, if the player's here, as an example, then the AI could shoot them, but then the player can shoot back. There's no protection for the AI in this place. But shadow is a good spot. Maybe they won't get seen right away, unless the player somehow uses some kind of detection, some kind of sensor system, or maybe just goes into the shadowy place or gets closer, or maybe there's some kind of like shiny quality to their armor or something that the player can detect visually. Okay, that's something that could happen as well. So again, different opportunities: only cover, cover and shadow and sniping. It's kind of rare to have something like this where you have sniping, cover, and shadow, where there's a bunch of barrels and they're inside of darkness, and then the AI can pop out, as an example, at a player, snipe at them, and then pop back into cover, and then the player would have to either move to try and shoot them, or try and shoot through the barrels, which is probably going to provide some kind of protection for the enemy AI. All right. Again, these are all just very simple examples about a few different kinds of tactical locations that we can consider, and there are others. So again, in most games, we have a set of predefined tactical qualities that we're going to assign to path nodes. Okay, so things like sniper, shadow, cover, ammo, whatever you want. And it's, again, sufficient to support interesting and intelligent tactical behavior, right? So you want to use the path nodes. Remember, our path nodes that we've given you already in assignment 3 and 4 are packed with information already, right? They're in themselves, they're also agents, if you remember how they work, right? So they have a lot of information. They provide things like line of sight. That's one thing that's not in here as well. How about the line of sight? Can I have line of sight between me and the player, between the player and me? As an example, that path node, kind of thing has a lot of information. It can have other information too, between, let's say, two different AIs and each other. Do I have line of sight between me and my companion, right? Is that possible? So again, when we think about other types of information, let's think about sniper locations for a second. They can be decomposed into two separate primitive tactical requirements. So I need cover to have to do good sniping, and some kind of view of the enemy, or, like we've talked about pretty much for the second half and some part of the first part of semester, line of sight. Okay, so this line of sight, as an example, is, these sight lines, if you will, are something that we've built in for you for assignment 4 in the path nodes. Again, if we support both cover points and high visibility points, line of sight, in our game, we can simply say that sniper locations are those points that both cover points are both cover points and reconnaissance points. So I can, again, reconnaissance points are places of surveillance, if you will, where I can kind of do some kind of, kind of viewing the character. I can kind of watch the character. Remember that in some games that are scripted, that the enemies won't even attack the player from cover, as an example, until they get to a certain spot, a place where they can get ambushed, right? Almost like what we like to call another waypoint, which is kind of like an ambush point. So they get to that point, and as soon as they get there, we spring the trap. We kind of, the AI kind of comes out and snipes the player or attacks them, bombs them, whatever they're going to do. So sniper locations, then going back to what we talked about, have a compound tactical quality because they're made up of two or more primitive tactics: cover, line of sight. Those two things, okay, that we're talking about. And in the same way, if we are looking at good locations to mount an ambush, like we just talked about, we could look for exposed locations with good hiding places nearby, right? So a good example is in the picture below. We can see that this is an exposed location, right? And but it's not as good as this one or this one, because this one, there's shadow. Here there's no shadow at all, which means chances are that your player is going to see the enemy AI, right? So these two places can be considered good exposure points, if you will, or ambush points. So when the player gets the spot, fire, right? Come out of hiding, surprise the player, attack them, and that kind of stuff. And those are great ambush points. So again, we've described, some waypoints so far, right? And they're usually separate, right? And usually in, some isolated location. There's no information as to whether one waypoint can be reached from another. Okay, we haven't talked about that yet. I mean, we have talked about it from an assignment 3-4 perspective, because again, you can set up a series of neighbors, right? You can kind of sit there and say, and we haven't talked about how to do that at all in labs, but you've already had some of that discussion from your pathfinding component in the course, which is, hey, what if I took each of those path nodes and made them intelligent, gave them neighbors, maybe 8 neighbors instead of just 4? What are the closest 8 neighbors around? And what's the closest path? If I was going to find the closest path between one path node and another using something like A star, how can I get there? How can I get there around cover or obstacles? Well, remember, what pathfinding does is it avoids obstacles because it kind of ignores them from a ignores them from a selection perspective. I'm not going to select a waypoint that goes through an obstacle. I'm going to go around it, right? So pathfinding could be your solution for something that you're going to do in A4. So we can use these waypoints as tactical locations, but even if we aren't using pathfinding, we can link together tactical locations to give access to more sophisticated compound tactics. So even if, let's suppose I'm not even using pathfinding, I'm using something like steering behaviors. So do I see them? Yes, I do. Okay, I'm gonna seek to that point. It makes it kind of more realistic because pathfinding makes it more mechanical in some ways, because the AI knows exactly how to get there, the closest path. And they appear to be much more intelligent than something that uses, sensing and steering, right, to get there. Kind of what we do in real life. So let's suppose that we're looking for somewhere that provides a good location to mount a hit and run attack. That's a different kind of attack, right? In the balcony, we have location A, okay, as an example, with really good visibility of the room. And a good candidate for an attack spot. So this is kind of something we can do. Similarly, there is one other location in the small anteroom right here, location B, that might be useful as well. So that's kind of a couple of locations that we have here, right? So remember what a hit and run attack is looking like. You kind of either snipe, right, and run out of the room because they're exit points, right? Same thing goes with here. A hit and run attack, I can snipe or attack somehow and then run out of the room, retreat basically, so to cause damage to the player. So the balcony is obviously better than the anteroom because it has 3 exits. So one down here, you go down the stairs, if you will. If that's one possibility, I can go out this door or this door over here. If we are looking to perform a hit and run attack, then we need to find locations with good visibility, but lots of exit routes. So this is a topological analysis. So we look at the level and we're looking at it not just kind of a flat view from a top-down perspective, but also, can I go higher up? Can I get an advantage somehow? And this is interesting. Let's just take an aside here and talk about advantages and disadvantages. Boons or banes, sometimes they're called in some games as well. And if you guys have ever played any kind of, you know, a desktop or a tabletop role-playing game, which is something we do, like we talked about earlier, higher ground is usually gives, your player a bit of an advantage. And actually Dungeons and Dragons 5th edition talks about advantages and disadvantages. If what they do is they allow you to re-roll your attack roll if you have an advantage, to get a second roll and take the highest value. So again, you're rolling a d20, 20-sided die, and if you have an advantage, you can roll another one and, again, take the highest total, as opposed to, so you could have missed, but you have another chance to kind of hit, which really is an awesome tactic, an awesome mechanic, if you will, to add in a game. Similarly, on the other side, you can also get disadvantage, which means you roll 2 dice and then you take the lowest score, which is always damning. It's terrible whenever that happens. So I'm talking about this because, again, areas of good visibility might have, especially on a higher platform, could have some kind of advantage in your game. From a gameplay perspective, you could give a buff, as an example, to your AI to do more damage, or to hit more accurately, or whatever it's going to be, because of the level of visibility. So topological analysis, what that is, it kind of looks at the structure of the level, and it looks at the properties of the waypoint graph. So we have a graph of waypoints, or nodes, if you will, and it looks at each of the properties within those nodes, and it kind of figures out what are the best locations for your AI to kind of go to, depending on the type of attack or action that they want to perform. So it uses the connections between waypoints as well as their tactical qualities and positions. Okay, so that's what it does. Topological analysis, it can be performed using the pathfinding graph if you really want to, or it can be performed on basic tactical waypoints. So you don't have to use pathfinding at all. It does require connections between waypoints, however. So one thing that we'd have to do to add this analysis, if you will, when the AI is making those determinations, is we need to connect the nodes somehow. Okay, back to our assignment 3 and assignment 4. Remember, in assignment 3 and assignment 4, and I'm just going to kind of bring up that right now, just to talk about what we did on Tuesday, just really briefly. And let's go to that thing we did with our Lab 8 just for a second, okay? So again, it's interesting to take a look at the pathfinding nodes we've already given you. Just gonna wait for this thing to load. There we go. And here's our Visual Studio itself, right? So I want to run this thing. It's just preparing our stuff. And when we run our project, remember what we're getting a lot of times when it decides to run. There it is. I was like, well, that's taking a while. It's probably because I'm doing so many things. All right, so remember that when we look at our debug view, we have a bunch of these waypoints. Okay, so here's an example of all the waypoints. Each of these waypoints right now, they're path nodes, and path nodes for your assignment 4 so far, this is the structure we've given you as a division scheme. They're not connected to each other, all right? They're not connected in any way. So if you think about that, if I go to the pathfinding itself, to the path nodes, and if I go to decision, right, and if I go to core, so we have decision tree, we have tree nodes, right, as an example, and under pathfinding, we have path nodes, right? Path nodes right now, we've kind of dumbed them down. I've removed some of the details that we had previously in the first part of your first half of your semester. So it's all around, basically all they really are just agents. All they are. And they have some information, right? Where they're going to draw them as, a different color based if they have line of sight or not, right? That's what really does it for us. If I have line of sight, I'm going to change the color of the path node, and that's really all that the path node takes into account. But going back to our previous, kind of things that we have done previously this semester, path nodes can also have path connections, right? And Alex introduced this idea of, path connections between one path node and the other, all right? So please don't forget some of the stuff that Alex discussed with you guys, because it's something that you can totally use to modify your path node to have a little bit more intelligence than just line of sight. Okay, just a note. And going back to what we said, right, this connection between waypoints is important, because once we have connections between waypoints, almost like neighbor nodes, if you will, and again, going back to our project that we're working with in our labs, let's say I run it, for example, here. And wow, this is taking so long compared to normal, which is bizarre because it shouldn't. There it is. So remember that if I was looking at a place that was safe, let's suppose I marked this place, you know, kind of in my game, if I was making this use of this game, and I marked this place right here as a potential hiding spot, let's just say, right? So, you know, it has to know the connections between the other nodes. There's a node here, there's a node here, there's a node here. These are the kind of the neighbor nodes that are next to it. So these are all the nodes that it has access to. It doesn't have direct access, let's say, to these nodes. And again, this is quite a dense graph that we've put together. You don't have to even have it this dense. You can have it a lot more sparse than this, right? To give almost like waypoints, selected waypoints that are, you know, less than these in order for you to get somewhere. Okay, that's something that we can do as well. So each node has these, and if I go from, you know, let's suppose one node to the other, then this node knows about, you know, these ones right here. So you can see that those nodes know about this node and this node and this node. There's 8 nodes here in this scenario, right? So 1, 2, 3, 4, 5, 6, 7, and then the one that's over here is hidden because it's behind a some kind of obstacle. All right, but each node, if you think about it, this node knows all of its neighbors, and each neighbor knows its neighbors. Then you create this idea of, you know, kind of a more dense, you know, kind of pathfinding algorithm that you can use. All right. And it makes actually, we've given you a limitation in the first half in assignment 2. We talked about pathfinding, and we said you can only have 4 neighbor nodes, and they have to kind of be up, down, left, or right. We didn't give you access to these nodes. So if this is your starting node, we said you can only do this when you're pathfinding, right? You have to avoid these ones. These ones are not accessible to you because we had in the previous lesson and the previous assignment, we only allowed you to go up, down, left, and right because you're working within a tile-based system. Here, there's no such limitation, so you could have 8 neighbor nodes, and that's why we made it possible for you to add additional neighbor checks, right, to make it more accurate. And that means you can go diagonal. I can go from this node to this node to this node, you know, kind of stuff when I'm hunting the best location or the best direction to get somewhere. All right. So that's kind of the demo, you know, from our lab. And without these connections, we won't know whether the nearby waypoints constitute some kind of exit route. Again, the waypoints aren't going to just have neighbor nodes. They're also going to have information on tactical information. It's a good hiding spot. It's a spot in shadow. It's a good place to snipe. It's got someone's at the door.
Someone is at the front door.
Mm-hmm. They always come to the door when I'm teaching. It's bizarre. You know, so again, all of these are potential spots, right? As an example, where you want to include that information in the path node. That's what you want. So unfortunately, this kind of information can be rapidly get complicated, and it's extremely sensitive to the density of waypoints. So why? Because remember what we just showed you. I've got, you know, 300 waypoints potentially on the screen right now. 300. Now that's not a huge amount of them. It could be denser. Remember, we're using our tiles, or our spacing is 40 by 40. And a lot of tile-based grids use something like 32 by 32 pixels or 16 by 16 even, right? So it can be even denser than what we've shown you already, right? So the more dense the waypoints are, the more computationally expensive it's going to be because they're going to carry more and more information, you know, in terms of, you know, how all this stuff is working, right? So the idea of this automatic topological analysis comes up from time to time. However, let's treat this with caution, okay? It's often way more painless, you know, as an example, to perform this process manually, which means to actually do some level design ahead of time and allocate points that are safe to go to, as opposed to having your AI decide that point for itself. Remember, one thing we said in the assignment 3 and 4, we never said it has to find things, randomly it's going to find 300 places where it can hide. We never said that. We said it needs to go to a cover point. That's where it needs to go to. You can decide what those cover points are, guys, to make it easier for yourselves, okay, as you do your assignment 4. So again, support more complicated compound tactics where we have multiple properties, tactical properties. We can move away from, these simple Boolean states, true, false, right, as an example. And rather than marking a location of being cover or shadow as an example, so true, I have cover, true, I have shadow, yay, I'm good. We can provide a numerical value. We've talked about numerical values in the past. We've talked about numerical values when it comes to utility theory. Remember, we kind of have a weighting, a number between 0 and 1, as an example, a point range, if you will. And usually those point range they're normalized, 0 to 1, where 1 is 100% and 0 is 0%, as an example, right? So for the purposes of clarity, we're using some kind of floating point value where the value of 1 indicates that the waypoint has the maximum amount of a property, whatever that is, and a maximum amount of cover or shadow, for example. And if an autonomous character is trying to find cover, right, and it has equally achievable options between waypoint with cover, let's say 0.9, so pretty good cover, really, really good cover, or cover that's 0.6, so there's some cover, but it's not a great location for cover, it should head for the waypoint with cover that's 0.9. Now, this is something you can curate, something that you can put in. You could also adjust it based on conditions. So you can say, well, right now, normally it has cover of 0.9, but guess what? The player has line of sight. Now there's no cover anymore. That can go down to 0, which means that the AI will not choose that place, right, for them to go. Okay, so again, tactical properties of a particular location are always sensitive to the actions of an autonomous character and the state of the game itself. So hiding behind a barrel might produce cover only if, like we said just now, the autonomous character is crouched, right? If the character stands behind the barrel, it's a sitting duck for incoming fire. Hiding behind protruding rock is of no use if the enemy is behind the autonomous character. So, the aim is to put the rock between the autonomous character, the AI, and incoming fire. So the problem isn't just limited to cover points, right? Cover points are good when you plan them, but sometimes things can go awry even with your planning based on the evolving state of the game, whatever that is, right? So any of these tactical locations we've talked about so far, shadow, cover, sniping, position, whatever, ambush locations, they all can change and they can become invalid depending on the evolving state of the game, so the new circumstances. If the enemy manages to mount a flank attack, so the player, then there's no use heading for a withdrawal location. They've flanked you, right? Which is now behind enemy lines. You have to do something else. You can't, withdraw. You have to fight your way out, as an example. So really there are two options for implementing context sensitivity. So here's option 1. We could store multiple values for each waypoint. So again, example would be cover points are shown with their quality of cover in each of the 4 directions, right? And the autonomous character works out the direction to each enemy and determines that it needs cover from the south and east directions. So the autonomous character checks for a cover point that provides that cover and selects cover point A. So here's the example. So in the first example here, cover point A has cover between this enemy here and this enemy here. And if I was going to draw a line, let's do that. So you can see that this point has no line of sight from either one, right? There's no line of sight between these two. And whereas this point, as an example, is not so good because you do have line of sight to this enemy. although you don't have line of sight to this one. So this is not as good. Cover point B is not as good for the autonomous character as cover point A. Okay. So again, predetermined directions of cover. That's what it is. Up, down, right. And here is just down. Okay. Let me just clear that up. So that's definitely one way. The other way would be we could use only one state per waypoint. So that's something else we could do. The autonomous character checks the line of sight from both cover points to both enemies, right? And if it determines that the cover point A does not have a line of sight to either, so it is a preferable cover point to cover point B, that is a line of sight to the enemy. All right, so that's what we just talked about. Okay. So far, so good. In most cases, though, an autonomous character's decision-making algorithm determines what kind of tactical location it needs, and this is simply achieved by querying the tactical waypoints in the immediate vicinity. So again, suitable waypoints, in our example, waypoints providing cover, are found, and any post-processing steps are taken to ensure that they are suitable for the current context. Post-processing steps might mean things like check to see if there's line of sight with the enemy of the AI. The autonomous character then chooses a suitable location and uses it as the target of its movement, and the choice can be simply to select the nearest suitable location. Alternatively, we can use a numeric measure of how good that location is, again based on a bunch of conditions altogether. Okay. So the simplest way to bring tactical information into the decision-making algorithm is to give the decision-making algorithm access to it, right? In the same way as it has access to other information about the game world. So if you want to use a decision tree in this example, and we've been talking about decision trees this second half of semester, we might make a decision based on the nearest cover point. Again, here's an example. Do I have ammo? Yes. Can I see the enemy? Yes. Is there cover nearby? Yes. Take cover. Right? I have ammo. And is there cover nearby? Yes. Take cover. Right? Do I have ammo? Yes. Can I see the enemy? No. Hunt the enemy, which is kind of like patrol. Right? Do I have ammo? Yes. Is there cover nearby? Yes. Right? Can I see the enemy? Yes. Is there cover nearby? No. Then attack. Right? Okay, we don't have any cover. As an example, might as well attack the player anyway. And you can see how this works. So cover and no cover, can kind of be worked into our decision tree, as opposed to something that's happening after the fact. Like up until now, our current decision tree, doesn't take into account cover except when we get hit, right? So there's nothing that's wrong with actually staying in cover the entire time, popping out, attacking, and popping back into cover, right? I mean, that's really not what we asked you to do in assignment 3 and 4, but it's kind of neat, right? If you kind of did that. Again, one thing to notice is distance isn't the only factor taking into account, however. So remember that, sure, this is the closest cover point to the character right here, right? But the problem is it's going to have to go through, it's not really the closest point, right? Because if I was to draw, you'd have to go around here and go here, right? Whereas here, you'd have to go over here. So even though this is the closest point as the crow flies this way, it's closest, you still have to take into account this barrier, right? So again, you'd want to use something like pathfinding in order for us to get there. If you weren't using pathfinding, this would be a problem, because if your character knew where this was, it would probably try and get through the wall, right? Somehow. That's why if you're going to make it more realistic, then you can only, go to cover points that you can see. That's something else, like or that you can detect itself. So here, clearly, maybe we can detect this cover point because it's within this area. Sure, it's not exactly in line of sight, but it's way closer, and it's kind of something that we can probably detect in the same room. Here, this cover point right here is outside the room, and we really can't see it. Like, so again, think about visibility, sight lines. If this was the ability for our character to see, can't see it. If we turn around and look around, and even if we had 360-degree sight, and if we assume that these barriers block our vision, right? But this barrier does not. Maybe for example, if this is a predetermined area, the player can see, quote unquote, this area, but it can't see this one. Okay. So, so again, the nearest waypoint is in an adjacent room and is completely impractical as a cover point. If we simply selected the cover point based on distance, we'd see that character run into a different room to reload, which makes no sense. We can minimize this problem with careful level design and, like I said before, pathfinding, the way walls are seen by the enemy and so on, or the AI and so on. So let's talk about cover points in a little bit more detail now, right? We've been talking about waypoints and different compound qualities of waypoints. So when we think about a cover point as a waypoint, the quality of a cover point is calculated by testing how many different incoming attacks might succeed, right? And we can run a complete simulation to determine how many attacks can get through, but this really takes time. Again, it's normally easier to approximate an attack by line of sight test, a ray cast through the level geometry, which is what I've been talking about with you and Alex too for most of the semester. For each attack, we start by selecting a location in the vicinity of the candidate cover point, which will usually be in the same or an adjoining room. We can cast a ray toward the candidate cover point, and this process is repeated for many times before from different locations. And we keep track of the proportion of rays that hit the target. This is something that we can do. Or we can do something like we did with our path nodes, right? Where the path nodes keep track of line of sight as well. So visibility points, which is kind of like line of sight, are calculated in a similar way to cover points. So where it's kind of the opposite. So I can see something. I want to be in a place where I can see the player. You know, as an example, I shoot a ray, and you know, I should be able to see I can kind of calculate the quality of visibility based on the number of rays that can hit that particular location from cover. Okay, that's how it works. So one thing that we also have to consider, and this works in tactical games as well, and we haven't kind of talked about this too much, is you know, firing arc. Okay, so firing arc is a big thing. And so firing arc and visibility arc are kind of related, right? So let's suppose our character can only fire, as an example, and it only has a 60-degree firing arc, right? It doesn't even matter what the visibility is, you know, as an example. If it's greater than, if a player is kind of out in the periphery, can't fire there, it's got to turn to see the player or whatever. Here, this isn't the case. We're talking here about, you know, what the character can see based on the conditions. We're casting a ray, and anything that's blocking that ray, you have nodes, let's say path nodes or waypoints that can't be seen by the autonomous AI, right? And autonomous character. And those nodes aren't really considered, right? The only nodes we can consider are anything inside of the visibility arc, okay? So we have the visibility arc, right? Visible and non-visible regions, right? And then we also have, we can also take a look at areas of full cover. So based on the position of the character, because there's no way that this character here can attack anything inside of over here, right? And over here, there's no way. Areas of full cover, areas of partial cover. This is interesting. Again, in strategic or tactical games, or even tabletop role-playing games like Dungeons and Dragons, you have different kinds of cover conditions. There's full cover, maybe light cover, you know, dense cover, different kind of things that you can put into play, and all of those have some kind of debuff or a negative modifier to be hit, you know, by the attacking opponent, whatever that is. So, example, if I'm in light cover, maybe it's because I'm lightly obscured by something. I have, you know, kind of vegetation or something, and I'm hiding. Maybe I'm in camouflage, I'm in stealth. You know, I might get a bonus to my hiding, and you might get a minus negative modifier to your accuracy of attack if you spot me at all, right? As an example. And partial cover is kind of like that. So I get some kind of thing. Maybe I'm not completely behind something that's going to protect me, but it'll give you more difficulty in hitting me, right, with your attack. Full cover is like I'm completely behind a wall. I'm completely, behind a barrel. I cannot be seen. And if you fired, even if you knew where I was, it probably wouldn't be able to hit me, be ineffective because there's enough material between you and me that it would absorb your attack, most likely. Okay. Unless, of course, you had armor-piercing weapons or some kind of weird energy attack or flame attack that would go around the corner or something like that, or some kind of smart weapon. But for the most part, this scenario is really quite interesting and kind of relevant to what we're talking about. All right, so that's kind of what we talked about so far. Any questions around cover points or kind of tactical points that we've talked about? We've talked about a few different ones. There's many other types that you can think about, but we've talked about ways of strategies, coding strategies. How do I kind of identify the quality of a cover point? And the way I've done that is you can use Booleans, yes, but it's a lot of Booleans to keep track of. Remember, it's always better to convert our path node to data. So I have the quality of cover, the quality of shadow, the quality of sniping, the quality of rearming, the quality of whatever, retreating. You can put all kinds of stuff in there. And once you have all those numbers in there, depending on the action that they're going to take, an autonomous character is going to choose the place to go to with the highest quality numbers, depending on the action that they want to perform. All right, so let's talk about pathfinding. So far, we've talked about pathfinding, and we want to find the closest path, right? But when we talk about tactical pathfinding, that kind of combines the tactical analysis, the topological analysis we've talked about so far today, as well as pathfinding techniques we talked about in the first half of semester, right? So it can provide quite an impressive set of results when autonomous characters in the game move, taking into account their tactical surroundings, all right? So staying in cover and avoiding enemy lines of fire and common ambush points. So not just the closest path, but the most tactical path. So example would be, okay, so I have a room that I'm moving into, and I have a bunch of, it's a corridor, and there's a bunch of plants that kind of in these little alcoves. What the enemy could probably do is kind of duck behind the alcove. So if you came in there, you might not see him, and then kind of come out. If they're hunting you, if they don't see you, duck behind another alcove. Keep doing that over and over again as they continue to hunt you, while they're pathfinding the closest path to the exit, to the door, or whatever they're doing, which is kind of interesting. Okay, so the only modification is that the cost function, we've talked about the cost function being a heuristic evaluation function, right? Some kind of function like we're using Manhattan distance or Euclidean distance that we talked about in the first half of the semester, right? So we're modifying the cost function, and it's extended to include tactical information as well as distance or time. So it's not just the distance thing, it's, okay, now I'm going to add more information to my decision, the pathfinding decision I'm going to make, right? Okay. So really, when we think about, if we do a little bit of math, the cost of moving along a connection in the graph should be based on both distance and time, and how tactically sensible the maneuver is. And the cost of a connection is given by a formula of the following type. Again, this is cost is equal to the distance of the connection or time or other non-tactical cost function, and where WI, right, is the weighting factor, if you will, the initial weighting factor for each tactic supported in the game. So again, cover, shadow, sniping, whatever you want to do it. The capital TI is the tactical quality for the connection, right? And again, for each tactic, and I is the number of tactics being supported. So for every tactic being supported, what is the weighting factor for each of the tactics? Let's put them together. And you add that into the distance, and that's your total cost. So that's kind of a different cost evaluation function than what we had in the first half of semester. So to convert our location-based information into connection-based costs, we normally average the tactical quality of each of the locations that the connection connects. So, all right, that's kind of a weird statement, but it's almost like can I make it a number out of 1? I don't want to think about like 5 numbers, as an example. I want to use all those numbers and average them. What's the tactical quality of that thing? Is it a good tactical quality or not? And the higher number is what we're looking at. It's almost like I want to add all those things up, right? So again, think about this. If I want cover, sniping, and shadow, if I had all those 3 things in there, and let's suppose I had some variable values. One was the shadow was low, 0.2, let's suppose, and the sniping was good, 0.8, and the cover was awesome, 1. It's really great from a cover position. So 1 plus 0.8 is 1.8 plus another 0.2 because not so good for for shadow is 2 divided by 3, and that's 0.66. Okay, so you're looking like that particular that particular waypoint is 0.66 in terms of tactical quality, right? So, but however, this can be an issue. And here's an example of a conundrum that your character can get into. If I have a bunch of connected points and both this position and this position is good enough, right? As an example, depending on where you are, you're going to have exposure either from one enemy or the other, right? That's the thing. So which one do you choose? And that's what this is talking about, this figure. So again, we can modify the pathfinding heuristic. That's what we talked about when we're going to do some kind of tactical pathfinding, right? So it's not just the shortest point between 2 paths or path between 2 points. It should always return less than the actual shortest path length. Otherwise, the pathfinding algorithm might settle for a suboptimal path. All right. So it's like I want to make it even better. It's gonna have, when I add it all up, the actual distance between if I calculate the distance pathfind from A to B, what's the distance? The total distance. The total, if I added up the other part, it's got to be less overall than the total distance, or else I'm going to choose a path that's weird. Okay, that's what this is saying. And so again, we ensured that the heuristic was valid by using a Euclidean distance between 2 points. So I'm going to kind of calculate the distance as the crow flies. That's what Euclidean distance is. So the closest point between point A and point B, calculating the distance. Any actual path will be at least as long as the Euclidean distance and will usually be longer, right? And with tactical pathfinding, we're no longer using the distance as the cost of moving along a connection. Subtracting the tactical quality of a connection may bring the cost of the connection below its distance, right? In this case, a Euclidean heuristic will not work. We don't want that to happen. We want to use some kind of other heuristic because Euclidean distance is a lot of times what we use. And the most common graph for tactical pathfinding is the grid-based graph used in RTS games. Again, in this case, the connections can be generated very simply. A connection exists between 2 locations if the locations are adjacent. So kind of similar to what we talked about already. All right, so that really is my discussion about tactics. How do you make, kind of AIs, at the beginning, not just work together, but think about ways that they're going to take other information into account from as opposed to just working independently. What do I do? There's much more to this, and this lesson actually had more information. In the past, we actually included things like, how to create formations and a bunch of other stuff. Again, I think it's out of scope for what we're talking about in this course. But I think the great thing about this is once you have the tactical quality of each waypoint or path node, you can extend this to include multiple characters functioning at the same time. Okay, so that is the discussion here for this. Yeah, I know, Derek. It was awesome. I saw that there was a Steam sale. I think it was like $11 or something on Steam, which is awesome. I think, and same thing with Civilization. It was really, really low. So both Civilization 6 and I think in Age of Empires, there's some great strategy games that are out there that are really, really cheap right now and they're really fun to play. All right. Any questions around tactical and strategic AI? So again, I think there's some relevance here for your assignment 4. And what I want to do with the remainder of the few minutes that we have left over that I want to continue with is I want to talk about assignment 4 one more time. I know that we've kind of beat this to death and what the requirements are and so on, but I want to talk about it one more time because I have this sense that people still don't get fully or understand everything that is required for assignment 4. So then one thing to note is assignment 4, this is assignment 3, and assignment 3 was our foundation. And I talked about this as when we first started the semester, like without assignment 3, assignment 4 is impossible. So here's something. What if your assignment 3 is terrible? What happens? Kind of thing. Or your assignment 3 is very basic, but doesn't work exactly perfectly. Or what happens if you never handed in, you never submitted assignment 3, and now you need to do assignment 4 because, you need to pass, right? Because that's something you need to do. Well, I've talked about this with a couple of people, and I'll say it to you as well, the people that are here and recorded. What I will do is I will accept assignment 4 if you work on assignment 3 and build the pieces for assignment 3 as an example for your assignment 4, or improve your assignment 3 in assignment 4, and you talk about it in your video and you discuss your code. I will adjust your mark for assignment 3 so you don't, if you didn't hand it in, get 0. If it's not that great the first time, I'll boost it up. If you've made improvements to the foundation of assignment 3 in assignment 4, I'll do that kind of stuff to adjust your mark at the very end. Okay, so just letting you know. So assignment 3 is definitely the foundation, and it talks about what you need to do. Basically, all it is you create path nodes, which is like everything we've done in your lab. Labs pretty much up to lab 6 was all around creating path nodes and all that kind of stuff, where we started, right? And a collection of nodes that kind of go together, a debug view, debug keys, animations and sound effects. People lost marks because they didn't include animations and sound effects for everything. Player combat capabilities, where you have animations and all that stuff for your player combat capabilities. People didn't do that. If you included them in assignment 4, please talk about them and say, please adjust our marks for assignment 3 because we've modified the stuff. We didn't get this quite done for assignment 3, but now we've done it for assignment 4. Would you mind giving us extra marks? If you say those kind of things in the video, I will consider those things and give you marks, right, for assignment 3 that you couldn't get done. Okay, I want to be able to help as much as possible. Again, not everybody is going to do that, or they have time to do it, because we're sitting here at Thursday and you have Friday, Saturday, Sunday, Monday. That's when it's due. Okay, and we're actually, you're going to show me your production on Tuesday. There's no time for you to be extended like normal. There is no extension possibility, right? If you think about this, right? Because if you ask me for an extension, when am I going to extend it? I have to see your video, or I have to see your presentation. So things are like, hard deadline is Monday for your assignment 4, right? That's how it's going to be, because next week is the last week of class. There is no other week that we can extend this to. All right, so that's what's happening there. Same thing with player health bars and health bars for everything else, obstacles, and a bunch of other stuff. Assignment 3 was the foundation for everything you need to do for assignment 4. If you did assignment 3 good, you're well on your way to getting things started for assignment 4. That's your assignment 3. So let's go back to assignment 4 now. So when we look at assignment 4 then, if we think about this for a second, assignment 4 builds on everything we've talked about in assignment 3. That's what it does, right? So again, mandatory criteria is an assignment 3 that's functional. That's what the mandatory criteria is. And we built a lot of these AI actions as stubs. It means there's nothing that they do, but we built a decision tree for the most part with you and in lab 7. That's most of the decision tree right there. What you need to do is make a lot of these actions work, right? I can do a ranged attack now. That's what's happening in lab 8. We talked about how to do that, right? But we haven't done wait behind cover, move behind cover. We haven't done those things with you. Move to range. We haven't done that with you. We haven't done, move to line of sight. These are all things that you need to do with your team, or flee. We haven't done those things, right? So you need to build all these things up in order for you to have a successful assignment 4, all right? The other things are, once you have your basics in there, you have 2 parts, right? You have conditions and you have actions for your decision tree. Okay, if you're going to use the decision tree. So, and we discussed really two loadouts. There's a close combat enemy loadout, and there's also a ranged combat enemy loadout. Guys, do not think that your close combat enemy loadout is correct, right? I've given you an example, right, as an example in terms of how it should work. The ranged combat enemy is closer to what you need to get done in order for it to work. We gave you an example of how to build a decision tree in the first part of Lab 7, right? It doesn't mean that this is the solution for assignment 4. It's just helping you with your thinking. People have asked me questions like, so can I use a Lab 7 as my assignment 4? No, that is not complete. It's just, the framework for what you're doing for your assignment 4. It's just helping you get on the way so that you know what approach we would take if I was going to do this assignment, kind of thing. Here's the other thing. Professor, I don't have any assets and I don't know what to do. Assignment 3 wasn't that great. Can I use your assets from assignment 4? No, you cannot. It doesn't make sense, right? Use your own assets, guys. Make an in-stream map. Don't make random stuff. Don't use assignment 4, lab 6 and 7 and 8 as your assignment 4. That's not the exercise. Lab 6, 7, and 8 is giving you subsystems, piece parts that you need to make things work. Remember, I don't need to move my obstacles around. The obstacles need to be destructible. There's a lot of stuff in here that we haven't given you that you need to think out on your own. And we can't build these things for you 100%. You need to do some of this work, with you and your partners. Okay, that's how it works. So just wanted to mention this because they've got like a lot of little questions, emails lately, and even direct messages. They're saying things like, hey, professor, I got this thing, and do you mind if I use your assets? No, yes, I do mind, because it doesn't make any sense. It doesn't make any sense for what you're doing. Unless you're going to ram the other player, the player with your ship. This is not a space combat simulation, that you're making, necessarily. We've given you space combat as a way of patrolling and moving your ships around, as an example. But you need to make an in-stream map. We haven't made an in-stream map. We just put like a background image. That's all we did, right? And our obstacles are just clouds, right? Which, again, they can't be destructible. What are you going to do to destroy clouds? That doesn't make sense. So, yes, we have a map. Is it 100% compatible with assignment 4? No, it's not. It's just an example. And all the labs are like that. They're just examples. They're just trying to get you rolling with technology, the tech behind what you're doing with decision making, so you can make it work. What if, here's another question. Can you copyrighted? Can we use copyrighted music? Yeah, it doesn't matter to me. For this, Michael, for this example, you can use whatever music or assets you want. It doesn't really matter as long as they're appropriate. And what I mean that is, they make sense. Don't just randomly pick assets and slap them together just to put something, in your assignment. Also, some warnings, and I got to talk about this. Making a funny assignment, quirky, funny kind of thing isn't fun for me. All right, I'll be honest. Not because I don't find it funny. I'm looking for functionality. If you make a funny sound or a funny animation, okay, as long as it has the functionality that I'm looking for your assignment. You're not going to get any extra bonus marks if it's humorous, as an example, unless the game kind of rolls together. So please keep that in mind. Keep it simple and straightforward, and all that kind of stuff. Yeah, but going back to what Michael asked, you can use copyrighted stuff because it's just for learning. We're not going to sell this thing. We're not using it for commercial reasons. It's just literally for practice and for education, right? So in my opinion, I think it's okay. All right. Any other questions related to the assignment? So I wanted to talk about this because, again, people have, some, kind of preconceptions about what they can do and what they can't do. Here's another one that I get. Can I use your GitHub repository? Can I access your GitHub repository? Can you use my code? If it's relevant, and if I've shown you stuff, then you can certainly use snippets of my code if it makes sense. Because we've just gone through labs and labs of stuff talking about decision trees. What am I going to say? No, you can't use my own decision tree. You got to make your own. No, that doesn't make sense. That's why the labs are there. They're there so you can use the code. Here's another one. I don't want to use a decision tree, Tom. Is that okay? Yes, it's okay. You don't have to use a decision tree. If you make it work and it looks and feels like what we've asked you to do, that's on you, right? I mean, AI, sometimes in the earliest games, was all hard-coded. It doesn't make sense, for you to do hard-coded stuff. Sometimes not, right? And that's why we're giving you decision trees. What if you wanted to use a state machine instead, or I don't know, something else? Go ahead. I've said that a bunch of times. Like, you don't have to use decision trees, but you just did a bunch of labs doing that, and there's a structure there for you. Why would you just reinvent the wheel and start over? Okay. Here's another one. Do I have to use your framework? Do I have to use the assignment framework? Yes, you do. Yes. Don't start from scratch. Please don't do that. That's not going to suffice. And here's the reason why. I need to know it's from you, right? A lot of times if you use some random framework, or if you do something like start off with, code from scratch, that's not going to, satisfy requirements. It's got to be something that we've talked about. If it's something wild and you're getting code from some random locations, I've never seen that before, and I've looked at your code for the entire time, and all of a sudden, suddenly, happily, you hand in code that's perfect, better than anything that I could do, that's probably a red flag, right? I mean, I'm probably going to look at that going like, where did this come from? Suddenly there's a bright light in their head, and then they got the ability for them to, to do the assignment. So please don't do that. Stick to the basics. Don't go crazy. Keep it simple as much as possible. And also look at low-hanging fruit, guys, right? The win condition is 2 points. Enemy respawning is 2 points. Destructible environment is 5 points. Look at these things and say, okay, where can I get the most marks for this thing, right? Because these low-hanging fruit it's not really difficult to accomplish. Some of the bigger points are more involved, right? There's a lot of stuff involved in these things, and we've given you some of this already, right? But there's going to be some of this stuff that might take a lot of work to get, and so there might be diminishing returns if you have a limited amount of time, right? Focus on where the marks are in this assignment. It talks about that right at the bottom in the rubric. So make sure you hit all the highlights, right, for this thing as well. Okay, so that is assignment 4, right, as an example. And I wanted to talk about this with you so that I've answered hopefully a few of your questions. That's one thing I wanted to do. I want to move on now to assignment 5, which is also due next week. Okay, so assignment 5, I want you guys to present, your, kind of your little game that you put together. And again, I'm looking at 3 factors, right, for your, for the presentation to happen. Okay, remember, this is worth, I believe, 6% of your final grade or something like that. It's worth something. So please don't take it lightly. Again, this is an opportunity for you to shore up some of your marks. Here's a question I always get. What if I don't have an assignment 3 or an assignment 4 and I want to do a presentation? The answer is you can't. You have to do an assignment 4 presentation. Your assignment 5 is based on assignment 3 and 4. That's why it's only worth 6% of your final grade. Okay? So if you don't have assignment 3 and assignment 4, your presentation's a dud. You can't do anything with it. What are you going to present? You, right? So you got to do something. You got to present something that makes sense. So again, when I say Friday, August 19th, this is the last day of class that the actual presentation materials are due. So what if on Tuesday when we get together, you have nothing and you don't have your final presentation ready until Friday? How could that be, right? Because your stuff is due on Monday, right, for your final release. Some people are going to be late. That's what's going to happen. And I've given you up until Wednesday to get your assignment 3 and 4 completed. So you may not be ready, to have your presentation done until Thursday, which is class time, our lecture. And that's why I said at the beginning, we'll see how it goes for, for the presentations I get on Tuesday, as an example, because if you're not ready for Tuesday, but you're ready for me for Thursday, you're not going to get full marks for your assignment. Your assignment's due Monday, right? Assignment 3 and 4, right? 4. And that means that if you submit it by Wednesday, you'll lose your 20% per day or whatever it is that Alex normally removes. And then that's it. The Dropbox closes by Wednesday, and then you should be ready to present by Thursday, because everything you've done by Wednesday. Worst case scenario. Here's something else. what if you're done, but it's not great? You're done, but it's not great. What do you do? How do you get full marks for this thing if you're not, if your quality of your actual release, the final product, is not that great? What do you do? What's going to happen? And the answer is, that's okay, right? If you can still present stuff that you've done, you're going to get marks for your presentation and your presentation value. This is kind of like the essential employability skills that we're giving you marks for this course. It kind of satisfies one of those outcomes. So things like the quality of your presentation materials, the body, your body copy, like what does it say, spelling, grammar, all that stuff, visual appeal of the actual presentation materials that I've talked to you guys about in your game production class apply here in terms of how you're going to present. Your presentation style, how confident you are when you're presenting, knowing your material, all that stuff, and the quality of your game demo. The quality of your game demo is where, if your project assignment 4 was terrible, is where you lose all your marks. All right, because but you need to have an assignment 4 that is somewhat functional. You can't just like randomly show up and go, well, the only thing I've got is your lab 7 and 8. That's all I have. That's my assignment 4, and I want to present. Nope, I won't allow it. It's because it's not your assignment. If you don't have a viable assignment 4 that you've put an effort into, I don't want to put effort into watching your presentation. I'm sorry, right? I mean, it kind of goes both ways here. And it's not because I want to put the screws to you or anything like that. It's because it's just not right, for us to look at something that's not yours. Okay, so please make sure that you understand that is something that we're looking for Tuesday. Okay. So again, look what it says. You must use your working assignment 4. Okay. You can't just present. Here's something else we've had before in the past. Tom, you know what? I'm doing a presentation because I want to get presentation marks, but I'm not presenting my assignment 4. I'm presenting my friend's assignment 4. You said assignment 4. It's just not mine. No, the answer is no. You can't do that, right? Nice loophole. No, it has to be your working assignment 4. If your assignment 4 is not working, if you can't actually physically click it and make it work, your presentation is a dud, right? That is a requirement. It's a mandatory prerequisite for your presentation. It doesn't matter how good your materials are if your assignment is not working. Okay, it has to be working error-free. All right, just letting you know. All right, you need a slide deck, and there are a slide deck of stuff very similar, eerily similar, to to the stuff that you put together for your production class. All right, so if you already have a slide deck for your production class and you're probably partnering with somebody that's in your team already, well, there's not a lot to do in terms of using your slides already that you've already made and just remanufacture them again for this assignment. There's nothing wrong with that, guys, right? Because your slides probably look good, probably organized okay, they've got some images in there and stuff like this of you and your partner already. You already have this kind of stuff, and you can qualify for some of these things that are in the slides already, right? One thing that is required for your assignment is a pre-recorded video, right? So even though you're presenting to me live on Tuesday, hopefully, I still want you to do a video as a run-through, and you're going to record it and submit it. This is part of the marks. It's worth 30 marks out of 100, 30% of your assignment for Tuesday. And your live presentation is worth 35 marks. So it's really your slide presentation, your gameplay video, and your recording. That's the stuff I want, as well as your live presentation that we're going to see you on Tuesday. Okay? So that's why there are 3 pieces to this whole thing. Okay, here we go. What if you're not ready, on Tuesday and you're going to present on Thursday? Will you lose live presentation marks? The answer is no, you won't. You won't lose presentation marks because this thing is literally due on Friday, the actual object, but you need to do a live presentation sometime, which is either Tuesday or, worst case, Thursday. There is no live presentation time on Friday. So it's either one of those 2 times. Friday is when all of your materials are due, just in case you haven't submitted your PowerPoint presentation material, that kind of stuff. That's all due on Friday. All right, it's just to clarify. Okay, and it talks about their submission requirements here. Questions around assignment 3, assignment 4, assignment 5. I mentioned assignment 3 because, hey, there's an opportunity. I'm giving you an opportunity for you to shore up some of the things you missed in assignment 3 when you're doing assignment 4, because you're doing assignment 4 anyway, right? There's an opportunity for you to get all those marks or a good portion of assignment 3 marks in assignment 4 if you do everything that I've asked you to do in assignment 3. Okay? Any questions at all? Otherwise, I have a couple people who wanted to stick around for questions. And for those people, just stick around and I'll try and answer your questions. So anyone have any questions around assignment 3, 4, or 5? Okay, I'm going to stop recording here now on YouTube. Thank you for the people who watched on YouTube. And just wanted to zoom back to, with you guys.